Alright, welcome back for lesson 2 here, or 2.1b. We are going to continue with parallel lines with the transversal, but now we're going to incorporate alternate angles. So this time, we actually are going to not just identify angles formed by two lines in a transversal, we are going to also draw the connections and reasoning between algebra and geometry, so you'll see that we're, just like we did, we're going to use algebraic equations to solve geometry problems. And we are now going to incorporate a little bit of proofs with applying theorems about angles to figure out how a theorem can be formed. So we'll see that shortly. And we're also going to prove theorems about parallel lines. Now, we had said with those two parallel, whether they're parallel or not, if you have two lines that are going in the same, if you have two lines that are running along and they have a transversal, they will form 8 angles. Now, for these lessons, the images are going to be shown as if they are parallel, so that's what we're going on for today. But in the future, I will show you examples where maybe they're not parallel. But also, please remember for this, we would say that the interior is between the two lines versus the exterior, which is outside of the lines. It's not quite a box here, so thinking outside the box, yeah. Now, for the interior angles, we have alternate interior angles. And if we have two parallel lines based on the alternate interior angles theorem, if there are two parallel lines crossed by a transversal, alternate interior angles are, well, if we look at those, angle 3, that is acute, and angle 6 lines up right with it, that is also acute. So we can say that alternate interior, I'm going to abbreviate for now, angles are congruent. And you can write the word, or if you want to, you can use the symbol, because they are indeed congruent. Alright, so like angle 3 and angle 6, those are congruent to each other. Just like angle 4 and angle 5, now we have an example of an obtuse angle lined up with an obtuse angle. So those two are also congruent. Now angle 1 and 8. If we compare those are alternate exterior angles. And the theorem that is provided here says that if two parallel lines crossed by a transversal provide alternate exterior, so here, let me go back. Alternate exterior angles, those are, when we look at those, one is obtuse, and actually the other one as well. So those are also congruent. So we could say that angle 1 is congruent to angle 8, or if you look at the bottom figure, angle 2 and angle 7, both of those are acute angles, and those are also congruent. Okay, so I fixed the mistake. Actually, I fixed it on this lesson. I didn't fix it on the previous one before, so my apologies. But what I meant to say was that adjacent angles like angle 1 and 3 or angle 7 and 8, those are side by side, so they are adjacent angles. Now, since they are also linear pairs, that means that each pair is supplementary, and that's what I meant to have last time. So if you wanted to, you could change it, but if not, don't worry about it. As long as we know that we have adjacent angles, now in these figures they are indeed supplementary. And then vertical angles, we can see those are still across from each other, whether we have angle 1 and angle 4, or if we have angle 7 and angle 6. Those still come together at a point, and they are vertical angles. So angle 4 is congruent to angle 1, or angle 6 is congruent to angle 7. Okay, on with the show. So, looking at the figure, we want to identify what type of relationship is represented. Looking at where these two letters are identified, we have X on the bottom right and Y on the top left. Those are exterior parts, and we can call those alternate exterior angles, which we call those congruent. So we could say that those are alternate exterior. There we go. Alright, number 2. We have Y side by side with X. Remember, those are referred to as adjacent angles. Alright, number 3. Another example here. Let's make sure we don't get caught by it, but Y and X, those are alternates, but they are alternate exterior angles here. Alright, number 4. Here we have an example of another set of alternates because they are alternating on different sides of the transversal. Now, since they're between the lines, these would be considered alternate interior angles. And it's kind of cool. You could think of like this little Z shape. I remember someone had said that if you have kind of like a Z shape here, the two angles that we form are the alternate interior angles. So okay, in this pair, when we look at Y, we look at X, those, based on the options, those would be vertical angles. They do come together at that point. Alright, speaking of vertical angles, number 7, we have angle question mark, nose up next to the 113 degree angle. So we can say that the measure of angle question mark is equal to 113 degrees. They are the same. For number 8, with 108 degrees, if we look at that as an obtuse angle, and we look at that top section with the question mark, that also is an obtuse angle. Guess what? Those are congruent. So the measure of angle question mark in this case is 108 degrees. Feel free to outline. If you find any special tips for outlining that really clicks with you, make sure to make a note of it. I'd love to hear what helps you guys to visualize any piece of this geometry. Alright, number 9, we look at this zigzag. Here we have these angle question mark. Some of you may look and say, yeah, well, from this lesson, all of them are the same measure. Maybe, maybe not. I don't know. But I do see one obtuse angle, and I see another obtuse angle. So the measure of angle question mark is equal to its alternate interior angle of 120 degrees. All right. Speaking of, for these, we have the 61-degree line, and we have its friend, which is seated right next to it, right here. Those are not just a linear pair, they are adjacent, but they are indeed a linear pair. They form that straight line. So, we can say that the measure of angle question mark, once we solve, would be the difference between 180 and 61 degrees, which when we subtract, we would have 119 degrees. Trying to make sure I give you guys on the other end of this video an opportunity to try and say it or visualize the answer before I get there. And again, don't forget, make sure to pause as needed to catch up with anything. So, alright. Now, for 11, getting back to drawing connections and reasoning with algebra and geometry, we need to solve for x. So, with the 25x angle and the 26x minus 3. That is that zigzag angle. It's maybe a backward Z, but it still is that same shape. So these are congruent. So we can actually create our equation. If we take, let's say, 26x minus 3 equals 25x. Or maybe some of you wrote that backwards. If you did, that's okay. In order to solve, let's subtract 26x from both sides, leaving us with negative 3 equals negative 1x. If we divide both sides by negative 1, we get x equals positive 3. Alright, so we found the value of x. For number 12, we see that we have two angles, and if you look at the top, we have this angle over here that's a lounging type of angle. If I've seen one, it's obtuse. It's like in a lounging chair. So those, the 12x minus 12 and the 10x plus 12, those are alternate exterior. It doesn't matter which type of alternate angle, they are congruent. So we can set those two equal to each other. So let's try 12x minus 12 equals 10x plus 12. Okay, when we solve now, that's a lot of 12s. Let's see. We subtract 10x from both sides, leaving us with 2x minus 12 equals 12. If we add 12 to both sides, we get 2x equals 24. Oh no, what's our answer? I thought the number was gone, but it's back. X equals 12. Alright. The revenge of 12 came back with a vengeance. Okay, number 13. We want to find the measure of the angle indicated in bold. So, we're talking about that top guy right there, 10x. We want to find the measure of that angle. And again, I still want you to stress, what is the relationship? I still want you to be thinking in your mind. The best thing you can do is reinforce any term or concept that we have just highlighted. So this 10x angle, that is, we could call it alternate exterior. They are on alternate sides of the transversal, and they are both part of some type of exterior. So we can set those equal. Let me fix that. Okay, so we have 10x equals 11x minus 6. Alright, solving this time, what I'm going to do is subtract 11x from both sides. So we have negative 1x equals negative 6. You don't have to put the negative 1, but since we know that we're going to divide it, it doesn't hurt to put it anyway. So if we divide both sides by negative 1, we get x equals positive 6. Now, remember, now that we've advanced a little bit further, we're going to find the measure of the bold angle. So now let's figure out what this would be. Taking it to 10 times 6, we can find that this bold angle is 60 degrees. Sounds fair to me. That looks like a 60-degree angle. Alright. I think we have... This might be the last one. Nope. Oh yeah, I forgot. We do have some proving to do. So, thought we were getting away from it, but we have some more to go. Alright. Now, for this, we want to identify what type of angles are these. These would be alternate interior angles. They make that Z, and they are congruent. They are congruent to each other. So, let's set them equal. So, 7x plus 14 equals 6 plus 8x. Alright, rules of solving. Well, let's keep x on the left. So we will subtract 8x from both sides. This time I'm going to write it just as negative x plus 14 equals 6. Okay? Now if we subtract 14 from both sides, cancel that out, we have negative x equals negative 8. And if we divide both sides by negative 1, we get that x equals 8. Okay. Now once again, we need to find the bold section. So let's figure out the 6 plus 8x. Alright. So we have 6 plus 8 times x is 8. Simplify. 6 plus 64. That would be a nice 70-degree angle right there. Slam dunk. Alright. Now, time for a couple of proofs. Well, we are going to prove and apply some theorems about angles and prove theorems about parallel lines. So, given that line K is parallel to line L, as you can see here, it is stated. And we have transversal T crossing through lines K and L. We need to prove that angle 1 is congruent to angle 7. So, let's recall. The first reason that we give in almost, well actually any proof, usually it is going to be given. Alright, that part was given. Awesome. Now, if these lines are parallel, that sets up some nice work for us. So we have angle 1 is congruent to angle 3. Looking at that, why would that be true? What kind of angles are these? Aha! They are vertical angles. So vertical angles are congruent. That is why. Now, for number 3, angle 3 is congruent to angle 7. That's the rule that was stated here. And if we look at that, angle 3, that is congruent to angle 7. What did we say today? First lesson, if you remember the relationship between those, that would be the corresponding angles. Now corresponding angles, what do we say about them? Those are congruent. And you could actually say it's the corresponding angles theorem if you want. That's because corresponding angles are congruent if parallel. So that's something we could write down. If two lines are parallel, then your corresponding angles are congruent. And finally, we have angle 1 is congruent to angle 7. So what we were trying to prove was that top right angle, angle 1, is congruent to angle 7. Now we can't just say that's because of alternate exterior angles. Actually, what we were doing in this is we were proving the fact that alternate exterior angles are congruent. So it is a two-step process here. Not bad if you look at it. So 1 and 3, those are, if you're looking at the relationship, those are vertical angles. And then if we jump from angle 3 to angle 7, those are corresponding. In just two steps, we could prove that angle 1 is congruent to angle 7. Alright, and proof number 2. This says, given that line K is parallel to line L, with transversal T crossing through lines K and L, we want to prove that angle 3 is congruent to angle 5. Alright, now some of you may have identified what theorem we are proving. Well, we are actually proving that those are alternate interior angles. But we're not going to be able to use that rule because we're going to prove that theorem. So, first, line K is parallel to line L, and so on and so on. That is given, given. Alright. Now, angle 3 is congruent to angle 7. If I get rid of that stuff from before, angle 3 here, congruent with angle 7. Why would that be true? Because those are in corresponding sections of your graph. So those are corresponding angles. Corresponding angles are congruent if parallel. Alright, and angle 7 is congruent to angle 5. Why would that be? That is because, take a look at these two, their noses are touching. Those are vertical angles. Alright, so we would say that vertical angles are congruent. Now, for that last part, angle 3 is congruent to angle 5. That is because of the transitive property. So, we have finished this. Now, I do believe it's high time that we talk about what is transitive property. It would be an excellent thing for any of you to put down. I'm actually going to give you a slide in the future, but let me tell you two parts. First, just before we conclude, we have the reflexive property. And that would be where if A equals A. That's, self-explanatory. Reflexive. It's like this A looks in the mirror and sees A. Fantastic. Next we have the symmetric property. And that would be the symmetric property of equality says that if A equals B, then B equals A. Well, if A equals B, then B also equals A. Sounds logical, I hope. And to the third one, these come in trios. This one is the transitive. And this one is a very crucial geometric property. I'll actually write property this time so you know what we're saying. The rule is if A equals B and B equals C, we can draw a connection. Then A is equal to what letter? C. A is equal to C. And that's using two parts to build logic to kind of put links in a chain together to say, okay, well, if A is equal to this and this is also equal to something else, then A is equal to that something else. A is equal to C. Alright, we are done with this lesson. Go ahead and get started with your assignment. Good luck. Also, if you feel like and you have a sign-in, you can maybe post some questions on the video. Just be kind. Alright, thank you.